Good afternoon, everyone. It's about 20 to 2 p.m. Eastern Standard Time on February 7th, 2016. I'm Weather Forecaster Eric Drewitz with your regional outlook. Across the region right now, we have temperatures in the lower to middle 40s in central and western New York, with some warmer temperatures down into Ohio and to our southwest over here, with cooler air well to our north and our east. So, moving into the 850 millibar pattern at this time, we have two areas of moisture that I'm looking at. This area, which is a developing coastal system, and then this Alberta Clipper that's coming out of Canada. And looking at the 500 millibar pattern at this time, we have this nice trough here associated with that upper level low that is the developing coastal system. We have this area of moisture, Clipper system here, and so from what I've seen, based on this pattern, the Clipper system looks like it's going to help force the coastal system out to sea. So areas such as Long Island, New York City, and the tri-state, you guys won't see that much snow, but areas of coastal New England, such as Boston and Portland, Maine, you guys could see a few inches of the white stuff. So here's the 250 millibar winds, and this is fairly significant because we have looks like the polar jet and the subtropical jet look like they're trying to converge. And when you have these two jets converge, that's when you get some explosive development for coastal storms. So looking at the current satellite imagery, infrared satellite imagery, we have this Clipper system over the Minnesota Ontario province border. So this should help push this coastal system out to sea more. Like I said, areas in the tri-state, they're probably not going to get that much, but areas over, coastal New England will definitely see a few inches. Looks like we have a little bit of a shortwave trough here associated with a cold front, so some cold air advections taking place over the northern plains right now. And current satellite imagery radar imagery shows decent banding, good banding of precipitation, heavy precipitation down here in coastal Carolina. Also, shortwave trough here moving over Michigan. And MODIS imagery of Erie. I can only find Erie for some reason, but that's fine. The only ice extent on Erie actually is this little pocket right here, and the rest is open water, which is significant because the past several winters, Erie's been almost frozen over. Erie, out of all the different Great Lakes, Erie is the one that freezes over the fastest and has the greatest ice extent because Erie is the shallowest of all the lakes. So, with Erie being pretty much all open water, this is a good sign that the lake effect snow season is going to be prolonged compared to normal due to these warm temperatures. So here's the NAO index forecasts, and the NAO looks like it's going to be fairly steady throughout the next few days. So it's not going to be a big player in this next week's weather, and I'll show you why. Because it's positive, which normally would indicate ridging in the east, but that's not going to be the case by middle of the week. So here's the PNA forecast, and this is more significant. So we have this little bulge right here. So that indicates more positive index of the PNA, which means that there's a greater favorability for higher geopotential height anomalies across the eastern Pacific and the western United States. So that's going to help build a ridge in the western United States, which will also help build a trough in the eastern United States. And now looking at the AO, now this is the most significant out of the three that I showed you. It really dips down. It really has strong negative signals in the middle of the week. And this is significant because this, what this does, first of all, this is the Arctic Oscillation. What this does is when you have a negative AO, you weaken the circulation around the Arctic. And when you do that, it allows for pulses of cold air to move southward easily, just like, the polar vortex. A good way to explain this for non-meteorologists is if you ever went to a fair or a carnival and you go on that ride, the Gravitron or the Roundup, it's a ride that you step on and it spins. You go against the wall and it spins you around really fast. So when you have to kind of put two and two together, when you have a positive AO, you have strong circulation around the Arctic. and that kind of traps the cold air in the Arctic, and it makes it harder for pulses of cold air to move southward. Tying this to the gravitron ride, when you're in the middle of the ride, so after the ride is started and it's accelerated and it's at its maximum speed, you're standing against the wall and you're pretty much pushed against the wall because of the force while it's spinning. So it's really hard to move off the wall if you ever went on that ride, any of those rides, while the ride was at its full speed. That's pretty much the same way of keeping the cold air trapped up in the Arctic. Now, when you have the negative AO, it's like the ride is starting to slow down, as an example. And then as you see, as the ride slows down, when it gets towards the end, it's easier and easier to pull yourself off of the wall. Well, when the circulation slows down there, it's easier and easier for pulses of cold air, quote unquote polar vortexes, to move southward than it is with the positive AO. So this is actually going to really help bring some cold air to the east in the middle of the week. So here's a few different things. This is the GFS ensemble mean 10 millibar heights and temperatures. So this shows some significant stratospheric warming over Russia and northern Asia over here. And that's actually going to be moving into in the western United States and the eastern Pacific. And that is actually going to help slow down the jet stream in a number of ways. So looking at current pressure anomalies too at this time, we have a big, strong, high pressure system over the western U.S. and the eastern Pacific. So that's going to also help create ridging in this region. Now, also looking at the 500 millibar height anomalies. Oh, wrong one. There we go. 500 millibar height anomalies. You see we have this really, really strong ridge in the western U.S. And all these factors together is going to help try to create a temporary block, which is going to slow down the air. And when you have blocking, or when you slow down the jet stream from all these, from stratospheric warming, the strong high pressure systems, and you get these, strong, either positive, these strong height anomalies, like in this case, high height anomalies over the west, low height anomalies over the east. To get these meridional patterns, it's easier when the circulation is slower, when you have like a block taking place. That's when you get to have these troughs and ridges really grow. Like last winter, we had the same thing happen in February, except it was for a different reason. It was because the PDO was very positive. We had very strong warm temperature, sea surface temperature anomalies off the southern coast of Alaska, which helped create ample ridging over the eastern Pacific and the western U.S. This time, like I said, it's from the Arctic Oscillation, not the PDO. The PDO is actually very, very weakly positive, and I emphasize strong on the very for the very weakly. So these factors can definitely enhance the troughs and ridges. Again, this is the Euro ensemble mean, initialized at 0Z. Strong positive anomalies in the west, negative in the east. So very ridgy in the west, troughy in the east. And this is for 0Z Wednesday, when the cold air's pulse is really going to start making its way into our region. So taking a look at the 250 millibar winds. So I was talking about the two jet streaks, jets merging, and it looks like they do by the middle of the week. And you get this really, really strong jet streak over here, getting into the Atlantic, and that could maybe cause some development, some good coastal development in the middle of the week. Now we're taking a quick look at the Canadian model, and it has the same exact output. This is for 0Z Wednesday. So models are consistent in these two jets merging, the polar jet and the subtropical jet. So that's going to be significant, because then you could have some explosive development. Now taking a look at the 850 millibar winds. I'll look at the Canadian first. First and foremost, this is the 12Z run, and I know a lot of you are thinking, oh, why is this area a gap right here? Well, these areas, the Rocky Mountains, so the surface is above 850 millibar pressure level due to its high altitude. So as you see in the middle of the week, when you have that strong ridge here taking place in the western U.S., we have strong warm air advection occurring here. But in the over the northern plains, northern Midwest, and in the east, we have some really strong cold air advection, especially over areas like Minnesota, Wisconsin, getting down into the central Midwest right here. And this is definitely going to crank up the lake effect machine, I think, because when you have strong cold air advection like this, first it looks like it's going to kick it up over Superior, but as time progresses, a lot of the Great Lakes should definitely have some lake effect taking place later in the week. Very, very cold air over the eastern U.S. Just take a quick look at the Canadian model right here to make sure they're lining up, and they do. Really strong cold air advection taking place over the eastern U.S. So definitely I expect the lake effect machine to crank up later this week. So now looking at the GFS 500 millibar vorticity, you see that two areas. This area over here is the coastal system that I was talking about, this area of upper level energy, and then this one is the Clipper system. And as you see, the Clipper system is going to kind of push the coastal system out to sea, but then it's going to kind of stall out over the northeastern U.S. So we're going to have pulses of upper level energy, looking at 850 millibar moisture and temperatures. Especially when you get into the middle of the week, like I showed you, some strong cold air advection over the Great Lakes with some decent 850 millibar moisture as this system pulls out, except for areas of pockets of dry air over here in the western Great Lakes. But I think the eastern Great Lakes has a good shot at some lake effect later this week. And then looking at the NAM right here, again, shows you the same thing. Clipper system pushes the coastal system out to sea, and strong cold air advection with decent 850 millibar moisture over the eastern Great Lakes. So I would not rule out lake effect. Looking at some precipitable water values and 700 millibar vertical velocities real quick. The core of the moisture from that coastal system stays out to sea, as you see in all these model runs, and the 700 millibar vertical velocities show very lots of upward motion in areas such as out to sea because of this coastal storm. You have those strong negative omega or areas that there's strong upward acceleration due to these strongly positive 700 millibar vertical velocities. Now taking a quick look at 850 millibar lapse rate over Lake Ontario here. Lapse rate definitely becomes more unstable later in the week. So this is 60 Friday, and you have areas of 10 degrees Celsius per kilometer dry adiabatic areas. So this is definitely going to help lake effect snow development. And as you see, as we move on, we have temperatures at 850 millibars almost minus 25 degrees Celsius with some decent 850 millibar moisture present. So I definitely would not rule out lake effect later in this week. It's too early to look at skew-Ts, but I'll do an update as the week progresses. But I'm definitely, after this Clipper system moves through, I'm definitely thinking a lake effect is possible, if not likely. So thank you all for watching. I will have an update as the week progresses, as we get closer to the Clipper system moving out. And this is Weather Forecaster Eric Drewitz signing off.